All right, so everyone here is for the MGF1106 final exam review, which is an accumulative review all the way from the beginning of the semester through now. So it will contain chapter 2, chapter 3, chapter 9, chapter 10, chapter 11, and chapter 12. There are a total of, I believe it was 43 questions I counted. Let me double check, scroll to the bottom. 43. So if you are here, then obviously you know that what this recording, it's under college mathematics and our online resource course that you can self-enroll into. Click on college mathematics, go to test review materials, and then that's where you will see everything. We are doing version A. So right there is a version that you can look at. I also have it up here on my desktop, so we'll be able to see it. You can download it. There's already a version B out there where this is the blank. This is the one that has worked out solutions. And this is the video of version B. Version A, we are going to be working on the solutions right now. And the video, once we are done, will be posted out here as well. So you have two versions of a cumulative final exam for MGF 1106 that you can look at. So let's get this party started. Here we go. So we got this first question, and it wants to know the roster of the following set. So we got our brace X line, where X, we got this symbol that looks like a giant E, and then this bold face N symbol, and then a compound inequality of 4 less than or equal to X less than 10, and then our brace. All right, so here's what we got. Let's first talk about this piece right there. What does that mean? X, whatever this is, and then this symbol that's right there. Kind of that bold N that we had. What does that mean?
That X is an element of natural numbers?
That's right. This means natural numbers. And what is a natural number?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up. Dot, 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 dot.
Yay. Absolutely right. Good job. And it just keeps going and going and going. Now, so we know what kind of numbers we're dealing with. All we have to do is list all the numbers that happen here. So all we have to do is, well, we know that we're going to start at the number 4. Or do we? So do we like the number 4?
Yeah.
Yes. Because we have that equal to under there. So we definitely do start at the number 4 and not at the number that's right above it, which is 5. So we know we start at 4 because we're equal to. So what's the next number we're going to start including in here?
5.
Keep it going.
6, 7, 8, 9, and 10.
So that's the question. Do we like 10?
No.
No, because it's not equal to. So you had it, Blondie. 4, 5, 6, 7, 8, 9. That is the roster. And there we go. So if we come back, I believe this was multiple choice. So we would select B. And I don't know. Yeah, your test is not all multiple choice, but these first few are. So just kind of give you a heads up on that. So this is, just so you know, coming from chapter 2. So the next one says, list all of the subsets. So remember that subsets are pieces of the original. So here's our set, C, Q, S. So what are these subsets going to be? Tell me who they are.
Q,
Yeah, one of them will just be Q. Because that is a piece of the original. What
Yep.
else?
C,
Yeah, we'll have C as a subset. What else?
S,
Okay,
CQ,
perfect.
CS,
Hold on.
Yeah.
CS,
QS,
okay, QS.
You have an empty set too.
empty set, yeah.
Yes, we're gonna have the empty set. So we're gonna put that right down here. So remember, empty set can be just two brackets or two braces with a blank. Or you can put the circle with a line through it, but do not do both. Okay, so we know that we got the empty set. Here's one more.
Oh, CQS, no?
Yes.
Yeah, between them, two letters.
CQS, because the set is a subset of itself. So there you go. So we have 1, 2, 3, 4, 5, 6, 7, 8 subsets. So there's only one up here, one answer up here that actually has 8 subsets,
A B.
and that's B. And there we go. Number 3. So we got this Venn diagram over here, and we want to answer the following situation. A, whatever this U shape is, parenthesis A, another U shape, B, parenthesis, and then a, oh, excuse me, and then a little exclamation mark. Or not exclamation mark, but gosh, apostrophe. Forgetting my words. So remember that when we went through this, that the first thing you guys will want to do is start working inside parentheses. So do we have parentheses?
Yes.
Absolutely. So we want to work inside here first. So the first thing they want to know, this A, whatever this U symbol is, B. What does that U symbol mean?
Union.
Union. And what are we looking for when we do a union?
What they got in common.
Well, not what they got in common. It's a little bit more than that.
Okay.
What they have in common is the intersection.
Okay.
What does union want?
Everything in both sets.
Everything in both sets. Everything. What they have in common and what they don't have in common. So what are all the numbers in A and B?
15.
Let's start from the lowest to the highest.
All right. 3, 5, 7, 11, 15, 17, 19.
You got it. Those are all the numbers that are in the circles A and B. All right. So now we've completed the parentheses. So we're going to work on the outside. Once you start working on the outside, the next thing you're going to work on is what we call the complement. Do I have any complements out here?
Yes, outside the apostrophe.
Yes, that's that apostrophe. So we want the complement of this set. What does complement mean?
Everything not in, it's outside of the set.
Correct. So give me everything outside my two circles.
23, 27, 33, 37, 49.
Perfect. 23, 27, 33, 37, 49. All right. And last but not least, we are now ready to do A, union the complement. But real quick, before we do the actual union of this, let's figure out what is in A. So let's go back. What is in just the circle A?
3, 5, 7, 11, 15, 17.
You got it. So what we want to do is we want to take the union of these two sets. So what's going to be our answer? We want the union of these two sets.
3,
Uh,
5, 7, 11, 15, 17, 23, 27, 33, 37, 49.
You got it. So pretty much every number but 19. Good work. And there you go. Oh, kind of ran off the page. So just as what Jody said, 3, 5, 7, 11, 15, 17, 23, 27, 33, 37, 49. Again, as I said, it's all the numbers but the number 19. All right, number 4. Cruising right along. So we've got parenthesis A, there's that union symbol again. B, parenthesis, we got that apostrophe, which we know is a complement. Now we got this new symbol, this upside down U, and the set C. And then they give us some information right below. So they give us the sets. So the first thing I would do is I would create the Venn diagram for this. So that way we can look at exactly what we have. So I'm just writing down the sets real quick. B, 1, 2, and 4. And set C is 1, 2, 3, 4, 5. Okay. So let's draw our Venn diagram. So it's going to be a 3-circle. And how I draw my 3 circles, I make my first 2 circles. And then I go right into the middle between these 2 circles and I draw a circle down. So we'll call this A, B, C, and out here is what we call the universe. All right. So where do we start filling in our Venn diagram at?
We will start with the one that the number, all the 3 circle has a comment.
That's right. We're going to start right here in the middle. All right. So what do all 3 of these sets, A, B, and C, have in common?
1, 2, 4.
Nope. Oh, and 4? Yeah. Sorry. My bad. So 1, 2, and 4. And so now we're going to come up here. We're going to cross these off because we're not going to use those again. Okay. So now you start to work your way around the outside. So what are we looking for right here?
A and B and
So between A and B, is there anything?
No.
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 Move on. What are we looking for right here?
B and C.
Anything?
No.
no.
Moving on. What about right here?
A and C.
5.
Okay. They both have 5 in common. So put the 5 there. Cross it all off because no one else is going to use that. Now, what are we looking for here?
Nothing. Anything else?
Nothing.
Yeah, anything left in A, but there is nothing because we got them all placed. Here for B,
Nothing as well.
nothing. C,
3.
we got a 3 down here in C because it's the only number we didn't use. And then anybody not crossed off is now where?
In the universe.
In the universe. So 6 and 7 are out here hanging out. All right, so now that we got the Venn diagram, it's going to be easy to do all this information. So again, we start with our parentheses. And inside my parentheses, there's no complement because it's on the outside. So we just take care of the A union B. So what is A union B going to be? What do both the circles A and B have?
1, 2, 4, and 5.
You got it. 1, 2, 4, and 5. Those are the numbers that are in both the A circle and the B circle. Okay. So now we move to the outside. We're going to take care of that complement just like what we did before. So complement, you said, is everybody not in here. So what numbers are not in that set?
3, 6, and 7.
Okay. There's the complement. And then now we want the intersection of this with C. Again, just to remind you, C, since we kind of did some crossing off, is 1, 2, 3, 4, 5. So what is the intersection? And I gave it away. I meant to have you guys tell me that this symbol is intersection. So intersection, as we talked about before, is about what they have in common. So what do these two sets, what numbers do they have in common?
3.
3. There's the answer. It is just the set 3. Moving on to number 5. Everyone good?
Yep.
Yeah.
Yeah. Yeah, nothing crazy. I don't
Yeah.
know why I just put number 5 on the floor. There we go. Jumping back. All right. Word problem. Yay. So you've seen this before. This is one of those 3 circle word problems all about rock, jazz, and classical. So I'm going to make my Venn diagram real quick. Rock, jazz, classical, universe. So just like before, I made my 2 circles and I went to the middle and drew a circle down. This one's going to be my rock. This one's going to be my jazz. This one's going to be my classical. So let's jump back. It says a survey of 73 college students was taken to determine the musical styles they liked. Of those, 24 students listened to rock, 21 to classical, 25 to jazz. Also, 12 students listened to rock and jazz, 10 to rock and classical, and 11 to classical and jazz. Finally, 8 students listened to all 3 musical styles. Construct a Venn diagram and determine the cardinality. All right. So where do we start with this?
We got 8 students listen to all the categories.
Good. So we know that the number 8 goes right here. And this is the only number from that word problem that we can trust.
Mm-hmm.
Because all the other numbers, when we put them into our Venn diagram, will be a little different. Okay, this is the only number we can take for face value. So we start to work our way backwards. So now we're going to come out here and we're going to work on this section. And what is this section about?
Rock and jazz.
Rock and jazz. All right. So what do we know about rock and jazz? Right here. It says 12 students listen to rock and jazz. But in our Venn diagram, remember, we've already taken care of 8 of those because that rock and jazz piece is actually this little football that's right here. This represents all the students that do rock and jazz. So this entire little football has to add up to 12. So if I've already taken care of 8, how many are right here? 4.
4.
Because 4 plus 12 is, or sorry, 4 plus 8 is 12. So you see that number 12 is here in disguise. This is why I'm saying we can't necessarily trust the 12 at face value. All right, so now we're going to move right over here. Who is this about?
Jazz classical.
Jazz classical. So jazz classical right here says 11, listen to classical and jazz. So we've already taken care of 8. How many are left?
3.
3. Because 8 plus 3 is 11. And then right over here, who is this about?
Rock
Rock
and
and classic.
Rock and classic. Perfect. So there are 10 there that listen to rock and classical. So we've already taken care of 8. How many are left?
2.
2. Because 2 plus 8 is 10. All right. What is this about here?
rock.
Rock. So we want to know the students that listen to only rock. Well, we know that 24 students listen to rock total. And again, just like before, this whole circle should represent 24. But we've already taken care of some of them. We've already taken care of 2, 8, and 4 students. So how many actually listen to rock?
10.
10. Because if I take 24 minus the 14 I have here, I get 10. So if I add all this up, this should be 24, which it does. All right. So let's go. Oops. Didn't tell you which category to look at. So right here is jazz. How many people do we know are in jazz right now?
25.
25. So we come back. How much is going to be right here?
10.
10.
10. Because this adds up to 15, and 25 minus 15, 10. All right. And last but not least is our classical. How many listen to classical?
21.
21. So how many are in here?
8.
8. I'm going to trust you on that. Because if I add these all up, I get 13. And 21 minus 13, 8. All right. Now, we know that college students don't all listen to just rock, classical, and jazz. There are many other varieties that we like to listen to. But we talked to 73 college students. So my question is, are there any others that might be out here in the universe? How do I determine that?
You add up the 3 groups, so 24, 21, and 25 give you 70. So 3 others are floating in the universe.
Careful.
Ooh.
You got to add up all these numbers. So you can't take the 25, the 21, and the 23. Whatever they were. You can't take those numbers. We can't use those. Because remember, some of these students have been counted twice in there.
Yes. So it's 45 altogether.
So you added all these up and you got how much?
I got 45.
45.
So 28 students are floating in the universe.
Ah, see?
Ah, big difference.
Yes. So 73 minus the 45 you said was 28. I agree. There you go. See, like I said, you can't trust a lot of these numbers at face value. The only one that we could actually accept was the 8.
Okay.
So there we go. So if I add all these up with 28, I get 73. All right. Now to the questions. The hard part is done. This is the hard part. All we got to do now is just figure out how many students are in different situations. Okay. So part A, they want to know how many listen to rock only?
10.
Yeah, absolutely right. Because when we come back here, these are the students that do rock only. Because these students all do other music at the same time. So I kind of coordinate this with symbols. So that's where this 10 came from with the star up there. All right. B. So this one says, how many listen to classical and jazz, but not rock?
21.
21. All right.
That's my,
So talk to me about how you got that.
you take everyone that listens because it says and jazz.
Mm-hmm.
Oh, so it'd only be 3.
Only 3. Why only 3?
Because it's and jazz instead of both.
So what does and mean, kind of like symbol wise? What are we talking about there?
They share in common, so union or
Not in common. You're thinking intersection.
intersection.
Or sorry, not union. You're thinking intersection because and is what means what they have in common. So, and the word not is like a complement.
Right.
So when you look at what classical and jazz have in common, it's really the football that's right here. But we don't want any rock. So you have to take out the 8, which leaves you only with the 3. We'll put a circle by that. That's where this number came from. All right. C is going to be similar to this. But this time it says that it is rock, classical or jazz, but not rock. So what does the or mean in this situation?
It could be one genre by itself.
It could be, or it could be both. So this is the union. We want the union of these 2 circles, and then we're going to kick out anybody that's rock. So the union would be all these numbers, because these are all the numbers in jazz and classical. But we're going to kick out anybody that's in rock. So that means that we're also going to take out the 4, the 8, and the 2, because these are all in rock. So there's the numbers you're only dealing with. 8
21.
through 21. So we'll do a triangle for these. So that's where the 21 came from, because we added 8, 3, and 10. D. So D says, how many listen to exactly one style? How many listen to exactly one style?
28.
28. Perfect. Let's do a little square for those, because you're going to take the 8 here, because this is only classical. You're going to take the 10 here, which is only jazz, and you're going to take the 10 here, which is only rock, and add them all up, which is 28. Perfect. I ran out of room. We'll do E and F at the top of the next page. So E. E says, how many listen to exactly 2 styles? And then I'm going to write down F right below it so I don't have to come back to this. N is none, which hopefully we know that one right away. So how many listen to exactly 2 styles?
9.
9. How did you get that?
I combine I want to say intersection rock and jazz. We got 4.
Mm-hmm.
Rock and classic. We got 2.
Mm-hmm.
Jazz and classic. We got 3. So I just add up all
There
of
you
them.
go. These are the sections where it's exactly 2. This is rock and jazz, as you said, rock and classical, and jazz and classical. So 4 plus 2 plus 3, 9. Let's use a wavy line for this one. Perfect. And finally, none. How many listen to none of these styles?
28, 21, 28.
28. The people out in the universe. So let's put a an equal sign. There you go. So 28. These are the people that listen to none. Perfect. The big key to this is making sure you get your Venn diagram right, because everything else is based on that Venn diagram. All right. Number 6. Number 6. So that was the end of chapter 2. Number 6 starts chapter 3. So in number 6, we've got let P and Q represent the following simple statements. P is, this is an octopus. Q is, I work hard. They want you to write the following compound statement in symbolic form. So the statement is, this is an octopus, or I work hard. We want the symbolic form, okay? And they're telling us that P is a statement, this is an octopus, and Q is the statement, I work hard. All right. So I like to use a little bit of annotation. So I'm going to underline my first statement. This is an octopus. So who is that?
P.
P. I circle any of my compound words. So what is the symbol for or?
V.
V. Absolutely. And then I underline my next statement. I work hard. And who is that?
Q.
Q. And all I got to do for my answer is combine all my little symbols. So it's P, V, Q. In my math lab, I would make sure that you use their symbol V. Don't just put in the capital V and think that it's okay. Check the symbols. When you click on the little piece right there, it hops up that little menu down here, your equation editor menu, and look for the V symbol. If it's not there, then yes, use the capital V. It should be fine. Okay, so there's number 6. Number 7, yay, truth tables. So the first thing we got to do is tell us what it is in symbolic form. So we got the statement that says, you did not do the dishes. Shame on you. And you left the car a mess. Okay. So I've got my sentence here. Again, I underline my first statement. You did not do the dishes. Anytime I see the word not, I put a box around it. So what does this really look like? You did not do the dishes symbolically.
Squiggly line.
Squiggly line because of the not and P. Oh, there's a compound word. What does the symbol and look like?
An upside down V.
An upside down V. I call it the rooftop or the caret key. Or you can think about it as the letter capital A without the middle piece in the middle. And then you left the car a mess.
Q.
Q. So there's symbolically what our statement looks like. Squiggle, P, carrot top or roof, Q. Now, the other thing they want to know is what are the real P and Q statements? What's the real P statement?
True, false.
Not whether it's true or false. I want to know actually what the statement is.
That you did do the dishes.
Yes. Take out the word not because this means negated statement. And the real P statement is you did do the dishes. What's the real Q statement?
You left the car a mess.
You left a car a mess, the way it is. So this is the information you need for the first answer. Those two pieces. I think this is a, yeah, this is a part A question. So part A, our answer would be you did the dishes. That's fine. And you left the car a mess. Squiggle P. Yep, it would be A. Because everything else is not correct. Now it wants us to construct the truth table. That's not hard to do. Hold on one second. So we've got P, Q, and then two other columns. Squiggle P, and then squiggle P and Q. True, true, false, false, true, false, true, false. All right. So, what does a negation do to a statement's truth values?
Flips it.
Flips it. So we're going to take this column of P and we're going to use it to help us with this column negate P. So what are my truth values then?
False, false, true, true.
Bingo. False, false, true, true. There we go. There's 4 of your answers. And then now you're going to take care of the and. So the and wants us to use the negated statement column and Q. Remember, we don't create columns unless we're going to use them. So we're going to use these 2 columns now. Ands are only what when what happens.
Only true if both of them are true.
You got it. Ands are only true if both truth values are true. So we have true, false,
False.
false. We have false, false.
False.
We have true, true.
True.
That's your true one. And false, true.
False.
Bingo. And there's our answers. So that's part B. Part C, little quick multiple choice. So part C says, use the truth table to indicate one set of conditions that makes the statement true. Okay. What are the conditions for a true statement? What do we know about P? And what do we know about Q?
When P is false and Q is true.
You got it. This is the only true statement. So that happens when P is false and Q is true. So we need to find a multiple choice answer where P is false, Q is true. So says it's true when P is true, Q is false. Nope. All the statements are true. No. No conditions, well, no. And D, the statement is true when P is false, Q is, there it is. D. Any question about number 7?
Yes.
Yes.
For section A, I see that you said you choose A.
Yes. Because if we go back and we look at what we wrote, the symbols is squiggle P, rooftop Q. If you look at A, squiggle P, rooftop Q, that's good. Our Q statement is you did do the dishes. Our P statement is you did do the dishes, or you did the dishes. It's the same thing.
Okay.
Our Q statement is you left the car a mess. P is you did the dishes. Q, you left the car a mess. That's everything that we wrote down.
Okay.
Okay.
I see.
You can't choose this one because this is a negation because it has the word not in it.
Okay.
So remember, to get back to the original statement, you just take out the word not. Cool beans, Blondie?
Yep.
All right. Truth table again, everybody's favorite. All right, so we got this big long statement up here. P and negate Q and then we got another parenthesis with P or negate P or Q, close the parenthesis. Now, this is one of those truth tables where I think they did us a disservice and they left off 2 columns that I think are important. So I'm going to put those 2 columns back in, which are the negation of P and the negation of Q. I think those 2 columns are important for this. And then we'll have their 2 columns or their columns that they have, P and negate Q. Actually, I said 2 columns, 3 columns. Then the negate P or Q, and then the whole sentence. Parenthesis P and negate Q and parenthesis negate P or Q. True, true, false, false, true, false, true, false. So this is what we got. I think they left these 2 columns out. I'm putting them back in because, I don't know about you, but it's a lot to try and keep symbols in my head at the same time and then determine truth values. It's easier if I can visualize it. So you already told me negations just change the values to their opposites. So what does the negation of P column look like?
False, false, true, true.
Yay. And using the Q column, we'll get the negate Q column. What does the negate Q column look like?
False, true, false, true.
Perfecto. All right. So now we're at the and. So P and negate Q. So that means we want to use the first column again. And we're going to use the negate Q column to help us, these 2. You already told me before that ands are only true when both are true. So I got true, false.
False.
Okay. Got true, true.
True.
Okay. Got false, false. And I got false, true.
False.
There we go. Now we're going to do negate P or Q. So we'll use the negate P column. And we will use the Q column. So ors are only what when what?
False when both are false.
False when both are false. Okay. So we're looking at negate P and the Q column. So these two. So I got true, false,
True.
True,
false, false,
false,
true, true,
true,
false, true.
True.
Okay. And just so you know, all of these are answers. Yes. These are all answers right here. Starting with these two columns. And now we're on the last column. All we're going to do is take these two columns we just made and answer the and to them. So again, you said ands are only true when both are true. So I got false, true.
False.
True, false.
False.
False, true.
false,
And false, true.
false.
There we go. Now there is one more follow-up question to this. It wants to know, based off of our final answers here, is it a tautology, self-contradiction, or neither?
Self-contradiction.
It is a self-contradiction. Remember, tautology means that it is all true, and that certainly didn't happen. Everybody was all false, which is what a self-contradiction is. Self-contradiction means that all answers were false. You're lying no matter what in the end. All right, so there we go. Moving on to number 9. So we want to know if the two statements are equivalent. How do we tell if two statements are equivalent?
Yeah.
What do we got to do?
So
What do we
the
gotta do?
final true value are the same for each case, right?
You got it. We got to look at their truth values in the end. And as long as they are the same for both in the same order, then they are equivalent. The moment one of them becomes a different answer, it is no longer equivalent. All right, just working up my truth table real quick. So here's what we know. We've got these two statements. They are conditional, so we got to be careful with those. So let's deal with this statement right here first. So what's the first thing we got to do in our truth table? What do you got to find?
Negate P.
We got to do the negate of P. We need that column. All right, so negate of P, as you guys have told me before, will be false, false, true, true. Now we can get to the entire statement. So negate P, arrow, Q. So this is a conditional.
Mhm.
Conditionals, you have to be careful because they are only false when what happens?
Ooh.
This is the one you got to be really careful on.
And then when the antecedent is true,
And
consequence is false.
you got it. So remember that the variable or the statement in front of the arrow is what we call the antecedent.
Mhm.
So that's this one. And the consequent is the second statement after the arrow. So this is the consequent then. So we're gonna look at it from this column to that column. From the antecedent to the consequent. So it goes false, true.
It's false.
Is what?
Oh, it's true. Sorry.
True. False, false.
It's true.
True, true.
True.
True, false.
False.
That's your false one. So we're going to look at this column. And if this one gets the same truth values in the same order in the end, they're equivalent. The moment one of these messes up on this one, stop, you're done. But before we can look at this final, what do we need to find first?
Negate Q.
We need to do a negation of Q. Negate Q. And then we'll be able to negate Q, conditional P. All right, so negate Q, as you guys have told me before, is false, true, false, true. We just take this column and negate it. All right, who's the antecedent in here now?
Negate Q.
Okay. Who is the consequent?
P.
Yeah.
Okay. So we're looking at it from this column to that column. So false, true.
It's true.
True, true.
It's true.
So far they're matching, so this is a good thing. False, false.
It's true.
True, false.
It's false. So they match.
So looking at those two columns, do they match 100%? Yes, they do. So these statements are equivalent.
Hmm.
All right, number 10. All right. Converse, inverse, contrapositive. So our statement is if dripless candles, I don't know why I'm having trouble writing candles. I wrote them as dandles. Candles do not drip, then wax will get on the furniture. Okay. So when we look at this, this is our conditional statement.
Mhm.
Even though this has a not in it, this is actually going to be our P statement. So I'm not going to call this negate P. I'm just going to call this P. And then this one will be our Q statement. So our original statement is P arrow Q because then is the arrow. So now we're going to go through and we're going to do the converse. What does the converse look like? Symbolically.
Mm.
So this is the conditional.
Be Q first,
Mm-hmm.
condition. I mean, I don't know. The little thing.
Q condition and
P.
then P. So all we do is switch the Q and the P.
Mhm.
What's the statement then going to be? If what?
Wax gets on the furniture.
Oops. Gosh darn it. If wax will get on the furniture. I know it seems weird. Or if wax gets on the furniture, same thing.
Mm.
come back and put in the word wax will get on the furniture. Then what?
Dripless candle did not drip.
There you go. And there it is. So if we go back, this is multiple choice. If wax will get on the furniture, then dripless candles do not drip. There it is. So it is D. Next one is the inverse. What is the symbolic notation for inverse?
Negate P,
Yep,
negate Q.
arrow, negate Q. So we take the opposite of what's being set up here. So if what?
Wax will not get on the
Careful.
finish.
Nope, it's not wax first.
Oh, if
Negate P. So here's our P.
Okay.
If
drip candles, if dripless candles do not drip,
no,
or do drip, or drip.
yes, do drip. Because you're taking the opposite of this.
Mhm.
So right now it's a not. So the opposite of a not is if dripless candles
Do
do
drip.
drip. Then
Wax will not get on the furniture.
there you go. Wax will not get on the furniture. And there you are. So if dripless candles do drip, then wax will not get on the furniture. And so let's see here. If dripless candles drip or do drip, same thing, then wax will not get on the furniture. Right there, it's B. And last but not least, for number 10 is the contrapositive. What is the symbols for the contrapositive?
Negate Q, arrow, negate P.
You got it. Negate Q, arrow, negate P. So what would be the contrapositive of our sentence? If what, then what?
If wax does not get on the furniture, then dripless candles drip.
There you go. If wax will not get on the furniture, then dripless candles do drip. Perfect. So we just go find that one. And if wax will get, or if wax will not get on the furniture, then dripless candles drip. So it is D. So D, B, D. All right. The next one says use De Morgan's law. Almost out of chapter 3 now. Use De Morgan's law. So it says it is not the case that It is time to go. Or it is 4. Okay, so they want to know which one of these statements down below is the equivalent. So remember De Morgan's law for us. Is how we conjugated and or statements. Oops. Or how we negated and or statements. Should have been P first. P. Let's make this the and make this the or. So remember, De Morgan's law is kind of like distributing through to each one of these sentences.
Mhm.
So that's a symbol for equivalent. So if I distribute the negation through to the P, that's going to be a negate P. What's the negation going to do to the and?
Flip it.
It's going to flip it, turn it into an or. And then the negation goes to the Q.
Mhm.
If it's an or, it will be negate P, turn it into an and, negate Q. So let's see which one of these we have, and then we can figure out which one is going to be the equivalent sentence. So up here, remember that I told you that this whole phrase that it is not the case that means negate with a parenthesis.
Mhm.
So I'm going to underline my first sentence. It is time to go. Who is that?
Q.
How about we call it P?
Okay.
Because we always start with P.
Oh, yeah.
We circle or. So what's that symbol look like?
V.
Okay. And then it is 4. So who is that?
Q.
Q. And then because we opened the parenthesis, we'll close it. So we now know that we are dealing with this one. Because we got squiggle, parenthesis, P, or Q, parenthesis. So I need you to take the P and the Q that we got up here and negate them, turn it into an and. What would that sentence look like?
It is not time to go, and it is not 4 o'clock.
There you go. That's the sentence they're looking for. That is the equivalent statement to what we have up here. It is not time to go, and it is not 4 o'clock. So if we come back, it is not time to go, and it is not 4 o'clock. Well, right there, it's A. And that's it. Number 12. So we want to know, is this valid or not? Is this valid or not? All right, so down here, we're going to translate this into symbols. Okay, first. And then it also tells us that P represents today, Bob got here soon. Q represents today, we're on time. And then we're going to figure out if it's valid or not. All right, so let me write some stuff down here. Bob got here soon, or we're on time. Today, we're on time. Therefore, today, Bob did not get here soon. Okay. So, got it written down. Underline my first sentence. Bob got here soon. What is that?
P.
P. Or
B.
B. We're on time.
Q.
Q. Today we're on time.
Q.
Q. Today Bob did not get here soon.
Negate P.
So our sentence looks like this. PVQ. Q. Therefore not P. How would this look if we wrote it out as a symbolic argument? Because we need that. So remember, the symbolic argument is going to start with a bracket. What's going to come next?
P.
Well, parenthesis. And then what?
PVQ.
PVQ
And parentheses.
in the parentheses. Because remember, inside our bracket, there's going to be parentheses for each one of these statements. What comes after that?
And again.
An and. And then what's our next one going to be?
Parenthesis. Q or Q.
Parenthesis Q, close it. And then there we'll end the bracket. Now, just so you know, there's nothing wrong with having parentheses around this. There's absolutely nothing wrong with that. My math lab, it will hate it. It will count it wrong. So when you're in my math lab, even though there's nothing wrong with this, we never put parentheses around a single statement. So you will not need those two parentheses right there. So even though it is not wrong, my math lab will hate it. All right. What do the three dots turn into?
Narrow.
An arrow becomes a conditional. And then what comes after my arrow?
Negate P.
Negate P. So this is what's going to go in one of these two blanks.
Yeah.
That's the symbolic form of the argument. Okay. Now we just got to figure out, is it valid or invalid? All right. So there's one of two ways, depending on what your professor is going to do. Some professors might give you that little sheet that tells you what's valid and invalid. Some professors will make you work out the truth table to this. So let's go ahead and do the truth table to this just to be on the safe side to cover all bets. But if you have the actual table, you should be able to see this in the table and know right away whether it's valid or invalid. Okay. So let me rewrite our statement. P, Q, Q, therefore not P. All right. So P, Q, true, true, false, false, true, false, true, false. This will be the last truth table. All right, so we're going to start working inside our parentheses, which is our brackets. And then notice inside those brackets, you got another parenthesis. So we need to take care of this piece first. P or Q. And as you told me before, P or ors are only false when both are false. So I got true, true.
Oh, sorry.
True, true is
True.
true. True, false is
False.
true. It's an or.
Oh, it's, no.
False, true is
True.
And false, false.
False.
Okay. So now we've done this part. So we're going to continue working in our brackets. So we're going to do the and now. We're going to take our P, V, Q, and Q. So we use the Q again and the PVQ. So again, an and is only true when both are true. So we've got true, true.
True.
We've got false, true.
False.
False.
True, true.
True.
False, false.
False.
Okay. Now we do need to get the negate P.
False.
So as you guys have done before, you know that it's false, false, true, true. And then now we'll do the entire statement, which is the conditional. Who is the antecedent of this conditional?
PVQ.
Say it again.
PVQ.
PVQ and Q. This is the antecedent column. Who is the consequent?
Negate P.
Okay. All right. So remember, you told me that conditionals are only false when the antecedent is true and the consequent is false. So I got true, false. What is this one?
True.
That's your false case. Antecedent is true, consequent is false.
I'm looking backwards.
It's okay. False, false.
True.
True, true.
False.
True, true is true.
Oh, I'm just kidding.
False, true.
False.
Nope, it's true. There's only one false case for a consequent or for a conditional. When your antecedent is true, consequent is false. So here's what we know. So based off this information, in order to be a valid argument, you have to be a tautology. Is this a tautology?
No. All of
No.
them.
So it is invalid. It is an invalid case. And in the blank, at the end of the invalid, you would put this argument. All right, number 13 is a Euler diagram or Euler. I could just call him Euler. Euler diagram, and that will end chapter 3. It says all snakes have forked tongues. No pigeons have forked tongues. Therefore, no pigeons are snakes. Okay. So remember, with Euler diagrams, we start with this. All snakes have forked tongues. So remember, this is about two circles and their relationships to each other. What does all snakes have forked tongues look like? What does all snakes have forked tongues look like?
Are you looking for like a variable or? a
So
circle?
this is like all A, R, B situation.
Right.
What do the circles look like? So we know that we have a circle.
For the A.
This is going to be your B, which is forked tongues. Now you have another circle, which is snakes. So how does that circle snakes work with this circle when it's all snakes have forked tongues? It's where?
Inside of the circle.
It's inside it. There we go. Snakes. So this is all A or B. All snakes have forked tongues. Now this one says no pigeons have forked tongues. So we've got another circle, pigeons, and it needs to interact with this diagram. So where would the circle for pigeons be in terms of no pigeons have forked tongues?
Outside of the forked tongue circle.
Outside of it, right? Over here. Pigeons. Now, the one question you have to answer when you're dealing with this other one, is there any way I can redraw this picture so that all this still remains true? Like, can I have the pigeon circle overlap any, or can I have the pigeon circle overlap with snakes? Is there any way that this circle could affect these circles in here? Any other way?
No.
No. So then the question is, based off of this picture, is this true? No pigeons are snakes.
Yes.
Yes. So this is valid. Done. Now, if there were other pictures, I would have to verify that this is true for it as well. The moment we have a picture where this is not true, it's invalid. And there you go. That's number 13. Moving on to number 14. Starting chapter 9. Yay. All right, so we want to take 0.021 millimeters and turn it into meters. So how can we turn 0.021 millimeters into meters? What are we going to do?
Divide by 10.
Divide by 10. How many times?
3 times.
How many times?
1, 2, 3.
Okay, just wanted to make sure. I thought you said 2 for a second. So you can divide by 10 3 times. So if you go to your calculator and you do that, your calculator is going to do something weird, I promise you. Divide by 10. Divide by 10. There it is. It's starting to do that weird thing. Divide by 10. So this is what it gives you. What is that on the calculator? What is it telling you there?
There's 5 zeros before. So you'd move the decimal 5 times to the left, I think.
You got it, because this is scientific notation. When you see that 2.1 e to the negative 5, when you see that, this means that this is scientific notation. It means that it's 2.1 times 10 to the negative 5, which, just as you said, it means that you need to move the decimal to the left 5 times. So if I take 2.1 and go 1, 2, 3, 4, 5, I end up with 0.1, 2, 3, 4, because these little hoops get zeros, 21 meters. Or the other thing you could have done, dividing by 0 is just like moving the decimal. So you could have just moved the decimal 3 times up here instead of having to move it 5 times. So you could have just moved the decimal 1, 2, and 3, and then put in all of your information. But there you go. It's just all about moving the decimal. And that E, if you see it on your calculator, means scientific notation. The E means times 10. And the number after it is its exponent. Here's number 14. Number 15, almost halfway there. So we want to convert 11 centimeters into inches. So remember, we're going to use dimensional analysis to help us out.
Mhm.
So there's got to be something over here that's going to help us convert between inches and centimeters. What is it?
1 inch equals 2.54 centimeter.
You got it. So this is our information. So what label goes in the denominator? Who are we trying to get rid of?
Centimeter.
Centimeters. That means inches goes in the numerator. And now you know where to put these numbers. The 1 goes with inches. The 2.54 goes with centimeters. And I just let my calculator do the multiplying. We go with 11 times 1 over 2.54. The other thing is make sure that you watch your rounding. It says to the nearest hundredth. How many decimal places is hundredth?
2.
So
2. All right. So I hit 11 alpha y equals to help put it in my fraction 1 over 2.54. So 2 decimal places. What do we get?
4.33.
Perfect. So 4.33 inches. Because 2 decimal places, the 0 says, hey, 3, stay cool. All right. Next one, we're going from ha, which is hectare, into acres. So we got 21.9 hectares. Again, we use a little dimensional analysis and we want to change that to acres. And it says round to the nearest hundredth. So what is our conversion we're going to use over here? What do we know about hectares and acres?
1 acre equals 0.4 hectare.
Yeah. All right. So what's on top then?
1.
1, because we're getting rid of acres. And that means the 0.4
Ha.
Denominator.
is in the denominator because we want to get rid of the ha. So we're going to take 21.9 and divide it by 0.4 or multiply it by 1 over 0.4. 21.9 times alpha y equals 1 over 0.4. And do we have to do any rounding?
No.
No, comes out nice. Gives us the 2 decimals. So 54.75 acres. Once we get past chapter 2 and chapter 3, it gets a little bit faster. Those are our long sections. All right, mixing up my stuff down here. Number 17. So we want to go from cubic feet into gallons. So what is our label going to be in the end when we do this?
Cubic.
Yeah, just gallons. If they wanted gallons squared or gallons cubed, they would have said it. It just wants to know how many, plain and simple, gallons. So we'll use dimensional analysis again, help us out. And it also says round to the nearest whole number. So what is our conversion we're going to use?
Cubic.
1 cubic foot.
1 cubic foot is equal to what?
7.4 gallons.
Okay, 7.48 gallons. So all we got to do, set it up. Who's in the denominator?
1.
1. And that means the 7.48 gallons is in the numerator. So really all you have to do is take our 44,952 times 7.48. 44,952 times 7.8. All right, to the nearest whole number.
336,241.
Perfect. 336,241 gallons. Gallons. So there are two answers to this one. You need to make sure that you get the number, and then you need to make sure that you select in the drop down the word gallons. 18. Little bit of temperature conversion, not too hard. C equals, oh, we got two temperature conversions. We've got Celsius equals 5/9 parenthesis F minus 32, or Fahrenheit equals 9/5 Celsius plus 32. They give us the temperature 32 degrees Celsius. They want us to turn it into Fahrenheit. Which formula will we use? The C equals or the F equals?
The F equals.
You got it. So all this is a simple plug and chug. So all we're going to do is take the 23, plug it in, and kick out the degrees Fahrenheit. Let's see here. It says round to the nearest tenth. What is the nearest tenth?
1 decimal.
1 decimal. All right. So we're going to take 9/5 times 23 and add 32. We'll just go to our calculator. And we've got alpha y equals 9/5 times 23 plus 32. And if it gives you the fraction, all you got to do is just divide the two numbers. 367 divided by 5. Do we have to round?
No.
Nope, because nearest tenth was 1 decimal place and it gives us 1 decimal. So the answer is 73.4. Easy peasy lemon squeezy. Just plug and chug. All right, number 19 will end chapter 9. So from below, we want to know which one expresses the weight of a giraffe the best. Gram, kilogram, milligram, or tonne?
Kilogram.
Kilogram, absolutely. Because the kilogram is the closest thing to like pounds. So giraffes are weighed in pounds. So if we're thinking about some of these other things like a gram, well, actually, let me start with the milligram. A milligram would be like a feather. I would measure a feather. Or pills, like pills that you take when you got headaches and things like that. Those are measured in milligrams because they're very, very light. Now a gram is also extremely light, but think of like a gram, like I would weigh a stick of chewing gum as a gram. Okay, because again, they're light, but it's a little bit heavier than a pill. So I would do like a stick of chewing gum as a gram, or like when I'm measuring dry ingredients like spices into a recipe, that's like a gram. Kilogram we talked about is like pounds. Tons, a tonne is like a ton. So, I mean, if we measure a giraffe in tons, that's one huge giraffe. So kilogram is the closest thing because it's like pounds. Number 20, chapter 10, all over geometry. So we want to know what is the complement and supplement to 36 degrees. Well, question real quick for you. What do we mean by complement?
90 degrees.
So I like the 90 degrees, but more specifically, it's two angles that add to 90 degrees. What do I mean by supplement?
I mean, the, the three numbers?
Two angles.
Yeah, I liked your 180. You should have went with it.
Yeah.
But it's the same idea. Just instead of adding to 90, they add to 180. I don't know why I put another plus sign. A little off of it today. So supplement is two angles that add to 180 degrees. So we want to know what plus 36 degrees equals 90 degrees. And what plus 36 degrees equals 180 degrees. That's what they're asking. So what do you think?
54 for the 90,
Okay.
and then 144 for.
And I will agree. That's it. Because all you got to do is really just subtract 36 from this, and you get the 54. Subtract 36 from this, you get the 144. Perfect. There we go. There's number 20. 21. All right. I love parallel lines. So we got X up here, and then 1, 2, 3, 4, 5, 6, 7. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 5, measure of angle 6, and the measure of angle 7. So we're after 8 different angles. And they did give us the angle X, which is a total of 121 degrees. And I'm going to go ahead and put that in my picture. Instead of putting X there, I'm going to put 121 degrees. That's what we know. So this is all about knowing terminology and some relationship of angles. That's all this is. So let's take the 121 and let's find all the angles that are 121 first. So who else is 121 degrees?
3.
3. The reason why we know these are 121 is because why? Do you remember the reason, Blondie?
They're vertical angles.
They're vertical angles. Absolutely. Vertical angles are always congruent. So these two are vertical angles. Who else is 121?
4 and 7.
4 and 7. So 4 and 7 are also 121. Perfect. And let's talk about why we know those. So the reason we know 4 is one of 2 reasons. These two are what we call yeah, there you go. Corresponding. Good, Jody. Because they're in the top left. Corresponding means they're in the same position. Or these are alternate interior, because we knew this was 121. So these are what we call alternate interior. And alternate interior are always congruent, as well as corresponding, as well as vertical angles. Number 7, you could think of it as vertical again, because we know this is 121. You could think of it as corresponding, because this is bottom right, or we get alternate exterior, and they're congruent. So knowing those relationships we just talked about helps you know other angles, because these lines are parallel, and that's the symbol for parallel right there. All right, so what must the measure of angle 1 be then?
59.
How did you get 59 degrees? And that is correct.
The total should equal 180 on those two angles. Linear
Yeah.
pair.
These two angles are exactly right, Jody. You got it. These two angles are what we call linear pair because they form a straight line. And remember, the degrees of a straight line is 180. So these two angles are supplementary. And so if I take 180 minus 121, that's 59 degrees. So the rest of my angles in here should also be 59 degrees. And again, for a lot of those reasons, once we knew this was 59, we knew that angle 2 was 59 because of vertical. Or again, you could think of them as linear pairs, which are supplementary. And then the same thing could happen down here. We knew that 5 and 6 are 59 because these are linear pairs. Or you can think alternate interior or corresponding. Same thing with 6, linear pairs or vertical or alternate exterior or corresponding. Lots of ways to work. All right, enough on 21. 22. So this one says right away, use the Pythagorean theorem to find the missing side. Let me draw my triangle real quick. A, 13 centimeters and 18 centimeters. It also wants you to tell us the label. What's the label of this going to be?
What was the question again, please?
Before we even figure out what the number is, what's the label of this going to be? Centimeters squared, meters, or centimeters?
The cm.
Yeah, you got it. Yeah, the label isn't going to change. These are in centimeters. These are in centimeters. Side A will be in centimeters. So you already know that your answer must be, at least for the drop-down menu part, centimeters. So there we go. All we got to do is run the Pythagorean theorem. What is the Pythagorean theorem? What's the formula?
A squared plus B squared got C squared.
You got it. So obviously they're telling you that you're looking for A, but we got to know which one of these is going to be the B versus the C. So who is B, the 13 or the 18?
The 18.
It is not the 18. That is not B.
13.
It is this guy. This is your B. Because remember, A and B are what we call the legs. And the legs form the right angle. This guy is your longest side, 18, and that's the hypotenuse. So don't forget that. This is a leg. This is the leg. A and B are always the legs, and this is your hypotenuse. So another way to think of the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. The legs always form that right angle. All right, so let's plug in. A squared plus 13 squared equals 18 squared. Well, A squared is just A squared. 13 squared, 169. 18 squared, I have no clue because I didn't memorize that one. So I just multiple. Say it again, Jody. 3 what?
324. 324.
324. Now what are we going to do?
Put number together. Let's do A squared equals 324 minus 169.
Perfect. So A squared equals 324 minus 169. So that's 155. Because all we did was subtract 169 from both sides. And then now, how do I get rid of something squared?
I forgot how they call it.
It's called a square
both sides.
root.
Yeah, square root
Root both sides. There you go. And let's go back. It says round to 1 decimal place. Cool. So A will equal, we'll go to our calculator, second x squared to get our square root, 155. Round to 1 decimal place. What is that?
12.4.
12.4, and it will be centimeters as our label. Perfect. Now we are definitely halfway through this exam.
Mm.
All right, so what was that number? That was 22, right? I think we're on 23 now. Yep, 23. All right, so this one is all about similar triangles. So it says use similar triangles to solve. A person who is 6 feet tall is standing 168 feet from the base of a tree, and the tree casts a 182-foot shadow. The person's shadow is 14 feet in length. What's the height of a tree? So I'm going to redraw this diagram really quick. Okay, so we've got a 6-foot tall person. We've got a 14-foot shadow. And we've got this other length of 168 feet. We want to know how tall is our tree. So there's what it looks like. So remember, this is similar triangles. If you can't see the 2 triangles in here, then my advice to you is to redraw them. There are 2 triangles in there. There's a large one, and then there's a smaller one. Okay. So do we know what this length of the large triangle is? If I'm separating these 2 triangles in here out?
No.
No, that's the length we're looking for. That's the question mark. Do we know what the bottom length of this triangle is?
Yes.
Yes.
How much is that?
182.
182 feet. Because that's what they told us about the shadow of the tree. The shadow of the tree is 182 feet. Which if I take 168 plus 14 feet, I get 182. So don't use 168 here. This number is meant to throw you off. You need to put them both back together, which is 182. And then obviously we don't know about this one because that's the sun. All right. Do we know how tall the little triangle is?
6 feet.
6 feet. Do we know how long the shadow is on the little one?
14 feet.
14 feet. And again, we don't know this length because that's caused by the sun. All right. So now you can see the big triangle and the small triangle. All we have to do is set up a proportion and cross multiply to solve. So Blondie, do you like to go from big to small or small to big? How do you like to set things up?
Small to big.
Small to big. So that's how this is going to be set up. So give me a number on the small one.
6.
And who does that compare to on the large one?
182.
No.
The
X.
6 does not go to the 182.
I mean, that would be 1 moment. Is it?
It's the unknown variable, so X.
It's
Yeah,
the
X.
unknown. It's the question mark. So we'll
Yeah,
just call
X.
it X, or you can call it question mark. It doesn't really matter. All right. Now give me something on the small, Blondie.
Is it 14? No.
You got it. That's the only other number. Now the last number on the large.
182.
There you go. See how everything's matching up.
Hmm.
This side corresponds with this side. This shadow on the person corresponds with the tree shadow. You're matching. All right. So as we said a moment ago, all we do is cross multiply. So 14 times X is 14X. And 182 times 6 is 1092.
So
How do we get X by itself?
divide both by X, 12, 14.
You got it. So X is equal to, what'd you get?
78
78. What's the label gonna be?
feet.
Feet, because it doesn't change. 78 feet, perfect. See, and then now you answered the other question, which was, what's the label? And you would select feet. All right, getting into perimeter and area and volume now. 24, so it says, find the perimeter. So we got this shape here. Drawing it out on my piece of paper real quick. Four feet, 4 feet, 9 feet, 6 feet. So looking at this, what's the label going to be?
Feet.
Feet, because it doesn't change. Everything's in feet. So you know that this has to be feet. Perfect. Now, how do you find perimeter?
You can add all the sides up or length times width.
Not length times width, that's area.
Area.
So, but you're right with the first one. Add all the sides up. But do
So-
I have all the sides?
No,
But yes.
No. So we still need to figure out this bottom side and this left-hand side right here. So remember, we talked about how we can take and we can break our shapes up into shapes that we know. Like if I draw a line right here, how long is this bottom length over here on the left side?
4 feet.
4 feet. How long is this bottom length right here on the right side?
9 feet.
9.
9, because these are little rectangles and opposite sides of a rectangle are congruent. So what is the full length?
13.
So now we know the bottom length. Now let's work on the left side. So again, we'll just break it up. We'll cut across right here. How long is the top left side?
4 feet.
4 feet.
4 feet, because you actually have a little square there. How long is the bottom left-hand side?
6 feet.
So what's the total left-hand side?
10 feet.
Now all we do is just add, like what Jody said. 4 plus 4 plus 9 plus 6 plus the 13 plus the 10. 4 plus 4 plus 9 plus 6 plus 13 plus 10. Because perimeter means all around the outside. What do we get? I already know the label is feet. What does all that add up to?
$36.
Say that again.
36.
Are you saying 36?
Yes.
Not 36.
Okay.
You're a little shy.
I think I missed one of the numbers. Got it.
46 feet. Just add it all up. All right, number 25. Let's jump to that one. So 25, they are giving us a triangle. I'm gonna recreate it on my piece of paper. 16.1 yards, 16.9 yards, 8 yards, 2.4 yards. Okay. Real quick, we are asked to find the area of this figure, and we know it's a triangle. But what will the label to this be since we are finding the area?
Yard square.
Yard squared, yard squared. Good. All right, yard squared. Okay. So what is the formula for the area of a triangle?
It's one. I mean,
Yeah, 1 over.
1/2 base and height.
There you go. 1/2 base times height. So up here, we only need 2 numbers. They've given us 4. So 2 of these are junk.
Mhm.
Which numbers up here are the base versus the height?
The height's 2.4.
You got it. This is the height because it's connected to that right symbol. And I also told you, remember that the basis is connected to that right angle symbol. So who's the base?
X. You don't
No.
know.
We know the base.
Hmm.
It's one of these 3 numbers.
This, yeah.
9.
Which one is the base?
The base in the down, right? That they want.
Base
Is it
doesn't
9.1?
necessarily, as in 9.1. 9.1 is the base, but just so you know, the base doesn't always mean it's the bottom.
Mm-hmm.
Okay. Remember that the base and the height are connected, are the 2 numbers connected to this symbol.
Gotcha.
2.4 is connected, and this base is connected to that symbol, 9.1. So all we do is you just plugged all that in and then do whatever rounding they tell us to do. So we're going to go to our calculator. Let's see here. What does it tell us to round to? Says exact answer. So actually no rounding. So whatever we put in the calculator, we want. So alpha y equals and 1/2 times 2.4 times 9.1. That's it. And you already told me the label is yard squared. Okay. Moving on to the next one. Any questions so far? Guys are doing great. Our favorite ones where they want exact answers and ones where they want in terms of pi. So we've got this circle, got this line that goes through the middle of the circle, and they tell us that that line is 24 yards. Real quick, since we're looking for circumference, what would the label be for circumference?
2 pi. Yes, I don't know how to say it.
2 pi radius. Okay, so you're telling me
Yes.
the formula, but what I want to know is what's the label going to be? We actually know all these
Yes.
labels.
Yeah.
Yards. You
Mhm.
bet it. Because circumference is the same as perimeter. So we're just going to be looking for the crust of our pizza. And that will be in yards. What would the area label be?
Yard square.
Yards squared. So 1 and 2, the label is yards. 3 and 4, the label is yards squared. And we will round to the nearest 10th when we do these. But the first answers we will get will be exact. All right. So you told me that the circumference is equal to 2 pi r, but there's also another one. What's the other formula for circumference?
2.
Not 2.
I mean,
Mm.
is it pi by diameter?
You got it. Pi d. So the question is,
I don't know how to say it in English.
yeah, diameter. You got it. So the question is this a diameter or does this represent a radius?
That's a Diameter,
You got it.
yeah.
So they are telling us the diameter is 24 yards. So if I was to find the circumference, which one would be the easiest formula to use for me right now?
Pi diameter.
Pi diameter. So the circumference of this circle, the crust, is 24 pi yards. That's the first answer. This is what they want because they want you to leave pi alone.
Mhm.
Then the second answer will be the rounded version of this to the nearest tenth. So we'll go to our calculator and we'll take 24 times pi. So calculator and 24. Second, your little exponent key right here is where pi is hiding. So second caret, and there it is. Hit enter. Round to the nearest tenth.
75.4.
You got it. And again, that will be in yards. So there's our first two answers. Exact and then rounded. All right, so let's talk area. What's the area formula for a circle? There's only one.
It's a pi radius square.
Perfect. So because we have the diameter, that means we need to figure out the radius now. How is the diameter related to the radius?
It's,
Say it
go
again.
ahead. Go ahead, Jody.
It's half, the radius is half the diameter.
All right. So a radius is actually half the diameter, or another way to think about it is your diameter is made up of two radii because there's one there and one there. So real quickly, we can actually figure out the radius to this because all we got to do, as you said, is cut it in half. So what's half of 24? 12.
12.
So we know the radius is 12 yards, and now we can plug in. So the first answer we want is exact. So in order to get the exact answer, we just need to square the 12. So what is 12 squared?
144? No.
So it is
It is.
144 pi yards squared because you already told me that label. So there's the exact answer. And then now all we're going to do is round it. We're going to go to our calculator, put in 144 and pi and round to the nearest tenth. 144 second pi. To the nearest tenth, what do you get?
452.4.
Four.
Perfect. 452.4 yards squared. Perfect. So these are the answers they're looking to. The exact circumference, the rounded circumference, and its labels. The exact area, the rounded area, and its two labels. That's number 26. All right, number 27. So we want to find the volume of this box. How do we find the volume of that box?
Length, wow, and height. That would be like a four cube.
Mm-hmm.
Yeah.
Because this is a cube, right?
Yes.
So if I want to find the volume of this, all we have to do is take the length times the width times the height. Or since it's a cube, because all the sides are the same length, s cubed. So it's 4 cubed. What is 4 cubed?
64.
All right. Label.
Foot square. No, I mean
Ah,
meter square. No,
meter's not
meter
squared.
cube.
Cubed, because it's volume. Meters cubed. There you go. That's number 27. So 64, and then you choose meters cubed. And I believe this is the last one. Yep. And then we're going to jump into chapter 11. So 28 is a lot like what we did on number 26, except this time we're talking volume, and we've got a cylinder. So the first thing they want us to do is find the exact volume. And then they want you to find the rounded volume. And we're going to round to the nearest whole number this time. Give me a second. I'm just writing out what I know. Okay. The label on this. What's the label going to be?
Centimeters cube.
You got it. So both of these answers are going to be centimeters cubed. So the question is, what is the formula for the volume of a cube?
Pi radius square height.
You got it. So, and we've got all the information we need. This is the radius. This is the height. So all this is a plug and chug. So pi, our radius is 8 squared. Our height is 10. So what is the exact answer?
For the pi version of it first,
Uh-huh. Remember, you're going to leave pi alone.
640 pi.
There you go. 640 pi, and you told me it was centimeters cubed. There's the first answer. Then all we do is we go to our calculator and we round for the next one. It said to the nearest whole number. The nearest whole number.
2011. 2000.
2000? I did not get 2000.
You did it right.
Did you take 6 or, oh, sorry. I put, hold on, joking. You're probably good. Yeah, 2011.
Yep.
I put in 460 in my calculator. So 2011 centimeters cubed. Because the decimal was 2010.619298, and the 6 says, hey, 0, up your game. 29. All right, so we're out of chapter 10. We're into chapter 11.
Hey.
All right, almost there, almost there. All right, so it says a person can order a new car with a choice of 5 possible colors, with or without air conditioning, with or without automatic transmission, with or without power windows, and with or without a CD player. How many different ways can a car be ordered? Okay, so remember that in the beginning of chapter 11, I taught you how to count out totals, like total ways different situations can happen. And it's either a fundamental counting principle, a permutation, or a combination. What is this?
Fundamental.
You are correct, because we have 5 different groups we're going to be selecting from. Remember, permutations and combinations only happen within one group. So we have colors, we have air conditioning, we have automatic transmission, we have power windows, we have a CD player. So we need to take and we need to multiply the total number of choices for each of these 5 groups together. So how many colors are there?
5.
There are 5 colors. How many choices for air conditioning?
2,
Okay, how many choices for automatic transmission?
2,
How many choices for power windows?
2,
How many choices for CD player?
2.
So this is the fundamental counting principle, putting that down on my piece of paper. So this is what you're looking at. So all we have to do is take 5 times 2 times 2 times 2 times 2. And what do we get?
80.
80? Okay. 80 new car orders. There we go. Number 30. So it says a club with 10 members is choosing 3 officers, president, vice president, secretary, treasurer. If each office is to be held by one person and no person can hold more than one office, and how many ways can these offices be filled? All right. So again, it's a counting principle, it's one of our counting techniques. Is it the fundamental counting principle? Is this permutation or is this a combination?
Permutation.
This is a permutation. Good. And the reason it's a permutation is because you are selecting officers, which means that there's a ranking here. The president is the best, the vice president is second best, the secretary treasurer is the third best. So whenever you're ranking, that's a permutation. So this is one of those NPR problems where the N represents the total number of choice or people you have or items. The R is how many you're going to choose. N is the total, R is how many you're going to choose. So if we come back to our problem, how many people do we have?
10.
How many are we going to choose?
3.
3. So you can tackle this one of 2 ways. You can run the formula, which the formula is n factorial all over n minus r factorial, which if you plug in, you get 10 factorial all over 10 minus 3 factorial. Or in other words, it's 10 factorial all over 7 factorial, which in the end is 10 times 9 times 8, 720 different officers. Or you can just let the calculator do this for you. Okay. So if you go to the calculator, you'll hit math, scroll over to prob. There's your NPR, which is number 2. Select it, hit 10, scroll over 3, 720. I prefer the calculator way than just doing what I did and writing out all that information. And again, the reason why I knew this was 720 from here is because remember, a factorial means that you're going to multiply from the top on down. So 10 times 9 times 8 times 7 times 6 times 5, blah, 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 blah. 7 factorial would look like 7 times 6 times 5, blah, 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 blah. And because these 2 repeat, the 7s cancel out, the 6s cancel out, the 5s cancel out, the rest of the blah, blah, blahs cancel out. So all you're really doing to figure out this number is taking 10 times 9 times 8. 720. But again, I just let my calculator do all that. I go to my calculator, I put 10p3. Done. 31. So this one is all about probability. They want to know what's the probability of rolling a 10. So we have a 12-sided die. the set of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the probability of rolling a 10. So remember, probability is what we want to happen out of the total. So how many ways are there to roll a 10?
One.
1. That's our numerator. How many outcomes are there total?
12.
12. So our probability is 1/12. And you always want to make sure that this is reduced. So, and it is. But if you didn't know if it was reduced, just go to your calculator, alpha y equals, put in the 1, put it over 12, hit enter, and the calculator will reduce it, which it already was reduced. Okay. Doing great. 32. 32. Another probability. So in this one, it says the table below shows the educational attainment of a country's population age 25 and over. Use the data in the table expressed in millions to find the probability that a randomly selected citizen age 25 and over was a man with less than 4 years of high school. So we want the probability being a man with less than 4 years of high school. So how many men have less than 4 years of high school?
12.
12. It's right here. 12 men, less than 4 years of high school. That's our numerator. Out of how many people total?
30.
Not 30.
161.
The 161 right here. This is the total number of people we talked to. So if you did the 30, then you're only talking about those with less than 4 years of high school. But remember, probabilities out of the entire total. So that's 161. So that's what the probability looks like, but we should always double check this. So alpha y equals 12 over 161. And it's good the way it is. So that's our answer. 33. So it says you randomly select one card from a deck of cards. Okay. So I hope you guys know a deck of cards. Or if not, hopefully your professor will provide you one. We want the probability that you're either going to select a 7 or a 9. Okay. So let's talk about this. When you're dealing with or probability, the first thing you have to do is you have to figure out if the situation is mutually exclusive or not. Do you guys remember what mutually exclusive means?
It's going to be used. No, I don't remember.
Okay. So mutually exclusive means they cannot happen at the same time. Like for instance, if I flip a coin, I cannot get heads and tails at the same time. I get one or the other. That's what mutually exclusive means. Okay. Like if I go to McDonald's and I want to have something outrageous like I'm hungry for the dessert of a macaroon. It's not going to happen at McDonald's at the same time. I'm not going to be able to buy a macaroon from McDonald's because McDonald's doesn't sell macaroons. Can't happen. Okay. So that's mutually exclusive. So the question is, if I pick a card, can I have a card that is a 7 and a 9 at the same time?
No.
No. So this case is mutually exclusive. Spelled that wrong. Too many twos. So what that means when you are mutually exclusive, it just means all you're going to do is find the probability of 7 and add it with the probability of 9. Okay? So the first thing is finding the probability of 7. What is the probability of drawing a 7 out of a deck of cards?
4/52.
You got it. There are 4 7s out of 52 cards. Because there's the 7 of hearts, the 7 of diamonds, the 7 of clubs, the 7 of spades. So we're going to add that with, what's the probability of drawing a 9?
4/52.
Because again, there's the 9 of hearts, the 9 of diamonds, the 9 of clubs, the 9 of spades. So we add these together and you get 8 out of 52, which will reduce. What does 8 out of 52 reduce to?
2/13. 2/13.
There you go. 2 out of 13. There's our probability. Perfect. All right, number 34. So 34 says, you draw 1 card from a 52 card deck. Then the card is replaced in the deck and it's shuffled. You draw again. Find the probability of drawing a 7 the first time and then a club the second time. So we want the probability of a 7 and then a club.
Which number are you at now?
I'm
33?
on, oh shoot, I skipped. I was reading number 35.
Okay.
I'm sorry. We are on 34. I
Yeah.
read number 35 though. So 34 says, a little different. Let's go back to that one. So 34 says that the mathematics department of a college has 7 male professors, 11 female professors, 11 male teaching assistants, and 5 teaching female assistants. If a person is selected randomly from the group, find the probability that the selected person is a teaching assistant or female. So this is an or again. So we want to know with an or all about whether it is mutually exclusive or not. So the question I lay before you is, can you be a teaching assistant and female at the same time?
Yes.
Yes. In fact, you see it right there, 5 female teaching assistants. So what this means is what we're going to have to do is we need to find the probability of a teaching assistant. We're going to add that with the probability of a being female, but then we have to subtract off everybody that we counted twice. So we need to subtract off female teaching assistants. Because in this case, you are not mutually exclusive. All right, so let's jump back. Let's find the probability of a teaching assistant. So what's the probability of a teaching assistant? How many teaching assistants are there?
16,
Out of how many people total?
34.
34. How'd you get the 34?
I added the 7 male professors, female professors, and both the assistants.
Perfect. And the 16 came from taking the teaching assistants and adding those up. 11 plus 5 is 16. All right. So we're going to add that together with, now we need the probability of female. How many females are there?
16 also.
Out of
34.
34. Now we're going to subtract off, how many female teaching assistants are there?
5 out of
5
30.
out of 34. So this is what we're looking at. 16 out of 34 plus 16 out of 34 minus 5 out of 34. And when you do all that math, you get 27 out of 34. Now the question is, does that reduce?
No.
No. So there's the probability. All right, now on to the real number 35. The one I tried to do just a second ago. So number 35 says you're drawing a card again from a 52 card deck. We want the probability that the first card, or sorry, once you draw the card, it is replaced in the deck, shuffled, and then you draw again. So what's the probability of drawing a 7? And then you're going to draw a club.
4 over 52.
Well, we're going to get to that. So
Okay.
when it comes to and situations, like the ors, we got to know what kind of situation we're dealing with. So the question for ands is, are they independent or not? So
They
the
are
question-
independent.
Say it again.
They are independent.
They are independent. How'd you know that?
So it's put back in the deck and shuffled.
Because it's put back in the deck and shuffled. We take the card and we put it back in. Okay. So when I draw the first time, I got 52 cards that I'm going to draw from. And when I put it back and draw the second time, I still have 52 cards. So that just means all we need is the probability of a 7. We're going to multiply that by the probability of a club. So what's the probability of a 7?
4 over 52.
You got it. Because there's the 7 of clubs, the 7 of spades, the 7 of diamonds, the 7 of hearts. We're going to multiply that with, what's the probability of a club?
13 over 52.
That's right. There are 13 clubs out of 52 because you got the ace of clubs and then you got 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you got 3 face cards.
Yes.
The jack of clubs, the queen of clubs, the king of clubs. So that's 13 cards total. So all we have to do is just multiply those together and make sure that it gets reduced properly, not property. What do you get?
1 over 52.
You got it. 1 out of 52. Because the original number gives you 52 out of 2,704. And that reduces down to 1 out of 52. Yay, yes. 36. We're doing so good. All right, 36 says Elizabeth brought a box of donuts to share. Yay, I love donuts. There are 2 dozen donuts, which 2 dozen means 24, all identical in shape, size, and color. 3 are jelly filled, 8 are lemon filled, and 13 are custard filled. You randomly select one donut, eat it, and then select another one. Find the probability that you select a jelly filled and then select a lemon filled. So are these independent or dependent? Because it is another and.
Dependent.
These are dependent. And the reason they are dependent is because the moment I take a donut, I eat it. And then when I pass it on, it's no longer the same box anymore. So you're minus 1 type of donut. And if there was only one of that donut, then and I just ate it, then you're out of those donuts for good. Because I'm not going to spit the donut back up and put it back in the box. That would just be gross. So what we need to do is we need to find the probability of a jelly donut first. And then we're going to multiply that by the probability of a lemon donut, given that we've already eaten the jelly donut. So what is the probability of a jelly donut? What?
3 over 24.
3 out of 24. Perfect. Now, I've eaten a donut. So how many are left?
23.
23. Good. So how many lemon filled are left?
8.
8. So there's the probability of the lemon. There are 8 out of 23. And so all we do now is multiply.
Before you multiply, can I do, I think that number will be, the first one, 3/24. Can I do 1/8? Is that possible to do it before or after?
1/8.
Reducing before multiplying.
Oh, reduce? Yeah, you can reduce these anytime you want. I always reduce them just at the end.
Okay, no problem.
Yeah, you can always reduce. So this is the unreduced answer if you multiply these fractions. But what is the final probability?
Oh, 1/23.
Perfect. There's the probability of eating a jelly donut, and then you're going to eat a lemon-filled donut. Okay. That ends chapter 11. Now we are on to chapter 12, our final chapter, 37. So it says a professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown by the following grouped frequency. How many students had at least 40 social interactions?
$16.
How'd you get 16?
You have to find how many number of social actions. So start at the 40 through 44.
Mm-hmm.
That's at least, so you can go all the way down to 59.
Okay. Yeah. So right here, at least means that we start at 40 and we go on up. So that means from 40 on up, we're going to add up all these students. And if you take 7 plus 4 plus 1 plus 4, you get 16. And that's it. There you go. There's number 37. Moving on to number 38. So you kind of seen this problem before. Most of these problems, if you haven't noticed, they are extremely similar to the questions that you've seen on previous exams, because that's how I made the final exam. All right. So students were asked, how stressed have you been in the last week on a scale of 0 to 10? And obviously this would be very important right now. With 0 being not at all stressed, 10 being stressed as possible, the students' responses are shown in the frequency table below. Construct a histogram and frequency polygon. So we want to know in part A, which one of these tables represents the histogram of the frequency distribution?
Bottom left.
Bottom left. Perfect. And reason why, look at what you got going on here. It says the bar for 0 should be at 3. The bar for 1 should be at 1. The bar for 2 should be at 4. So if you look at this first graph, that bar is way too high. It's practically up at 15. So you got to throw that one out. This one doesn't even have a bar for 0. So you have to throw this one out. You look at the bottom right, this one, again, the bar is too high. It's above 15. So these three graphs don't match what's going on for 0. But if you look at the bottom left, everything is lining up with what we know. Part B, all we need to do is find a graph that matches it as well. Okay? So which one of these graphs match that bottom right hand or bottom left hand graph?
First one.
The first one. Because again, this one looks just like the top right hand. That is too low. 0 should be up at 3. And these two right here, 0 is way too high. Again, above 10 or above 15, just below 15. These two don't match. So it's that top left. Matches exactly what we need. 39. And there you go. That's it. So 39, we're going to use our calculator to help us out to find the mean. How do you find the mean of data? What does mean mean anyway?
All the number
Mm-hmm.
divide by the total number.
You got it. You add all entries and divide by the total number of entries. So if we could do this by hand, but I'm going to show you how the calculator will work too, because there's some information I want you to be able to do in the calculator for standard deviation, because I don't want you to find standard deviation by hand. So you take 72 plus 77 plus 77 plus 79 plus 80 plus 83. Add all that up and divide by 6. So if I do all that, $72, just using my calculator real quick. Plus 80 plus 83. My top number is 468. Divide that by 6. I get 78. So I think it said that there's rounding. Yeah, round to 3 decimal places, but since it's nice and neat, I don't have to round to 3 decimal places. Now let me show you how I can do this on the calculator real quick. So on the calculator, you're going to go under stat. So you click on stat and you're going to go to edit. So in here, I'm just going to come in and replace these numbers. Or if you don't want those numbers here, you can come up and hit delete and then hit enter. Or there you go. Oh, actually, I just deleted my L1. So let me show you how you can fix that. If it doesn't start at L1, you can go to second and memory. And you want to reset just the defaults. So we can reset that. There we go. And my stat should be back to normal. Okay, it's not. Should have been. Yeah, we'll deal with it later on anyway. All right. It should have fixed it. So let's just go back. I'll just do an entire reset of my calculator. So we'll just say all. Only do this if you have programs in here, just so you know, stuff that you put under programs. Don't do the reset of the RAM because it will delete all of them. So now my list should be back to normal. There it is. So if I had numbers in here, don't come up here and hit delete, hit clear, and then hit enter. There you go. So you can put in your numbers, 72, 77, and it doesn't matter if they're in order or not. So I already put the numbers in order, 79, 80, 83. Then what you're going to do is you're going to go back into stat and you're going to go over to calculate and you're going to run this first one variable statistics. So you hit enter. It's list 1. Just come down to calculate, hit enter. And right there at the top, this X bar means mean. So there's your mean, 78. Also, if you're using the same data, right here is where you'll find the standard deviation, this SX, that's standard deviation. And then if you scroll down, Right here is the median if you ever need to find a median. So there's lots of good information in there. All right. So there's how we can do that problem. Let's jump to number 40. Losing my mic. All right, number 40, find the median. Hey, what do you know? Here we got to find the median. So if you're finding the median, what does median mean?
Middle.
Middle. 2, 3. So that means you got to put your numbers in order from the least to the greatest. So it's 21, 22, and then 23, 23. And we got a 24, a 25, a 27, and a 28. 2, 3, 4, 5, 6, 7, 8. 4, 5, 6. Okay, so I got all my numbers now. So median means middle. So all you're going to do is just jump your way to the middle. So we jump, we jump, we jump. Uh-oh. We're stuck between two numbers. What do we do?
Add them together, divide by 2.
You got it. Take the average. So 23 plus 24 divide by 2. So that gives us 47 divided by 2, which is 23.5. There you go. Again, we can go to our calculator and we can put all that stuff under stat. Let's scroll up, hit clear, delete. And then so 21, enter 22, enter 23, 23, 24, 25, 27, 28. And then now where would I go? Stat and where?
Over to calculate.
Calculate and the
Yeah.
top one. Go down to calculate, scroll down a little bit, and there's the median, 23.5. Cool. All right. So we're there. Last 3 problems. 41. Find the mode. What do we mean by mode?
I mean, the number that outfit the most.
You got it. The number that happens the most. Mode means most. So what is the number that occurs the most?
47.
47. So you'll select A and you'll put 47 in the blank. Because if you look at all of your numbers in order, 47 occurs the most. Almost there, almost there. 42. How do you find range?
Track the largest from the smallest.
You got it. Subtract the largest from the smallest. What is our largest?
24.
Okay, what is our smallest?
16.
10.
What is 24 minus 16?
8.
Okay, here it is, ladies and germs, number 43, the final question of the final exam. So it says, not everyone pays the same price for the same model of a car. The figure illustrates a normal distribution for the prices paid for a particular model of a new car. The mean is 19,000 and the standard deviation is 2,000. So you can see right here in a normal distribution, the mean goes in the middle. And then how we get these other numbers is by adding or subtracting that standard deviation. So 19,000 plus 2,000 is 21,000. Plus another 2,000 is 23,000. 19 minus 2,000 is 17,000. Minus another 2,000 is 15,000. So on and so forth. They want us to use the empirical rule to find what percentage of buyers paid between 15,000 and 23,000? Well, here's 15,000. Here's 23,000. What is the percentage between these two numbers?
95.
You have just answered your final question. And that is what the MGF 1106 final cumulative exam will look like.